So this is what we have for the slope now. And if we just simplify the denominator here, in the numerator we have f of x plus h minus f of x over, look at what happens here. It's x plus h minus x. The x's go away and it's h. So with this new process, when we bring the 2 points infinitesimally close to each other, we now have this formula to find slope. Okay? However, what we said is this whole thing is riding on the fact that h, which is the distance between the 2 points, is almost what? 0. So then this is going to be the limit as h approaches 0 of this formula. Okay? And this is one that you need to commit to memory, because this is going to be the formula that basically transforms the secant line into the tangent line. And when we find the slope of that tangent line, we have the best approximation of the slope of the curve at the particular point. Okay? Here is the formula that you have to memorize one more time. So let's do an actual example. Here, what we have to do is find the slope of the tangent line to the graph of the function at the given point. Okay? In this case, x is 3. So we want to find the slope at 3 and 9. Okay? X is 3. What we want to do now is also find what's f of 3? If x is 3, what happens when you plug 3 in here? It's 9, which is this point. So if this is x, then this is f of x. Okay? All right, so let's find the slope at this point. All right, so the slope is going to be the limit as h approaches 0 of f of x plus h minus f of x over h. Now, I'm given x, right? So I can plug it into here, these 2 points. So m is equal to the limit as h approaches 0 of f of 1 plus h, 3 plus h, right? X is 3, so I plug it in here, minus, what's f of x? 9 over h. So now I need to do some behind the scenes work. I know what f of x is. F of x is x squared. What's f of 3 plus h? We can do this from algebra. I remember we did it in the beginning of the year. So if this is f of x, f of 3 plus h is what we get when we plug this into x. So it's going to be 3 plus h squared. So this is, when we distribute the square, it's 9 plus 6h plus h squared. That's the binomial theorem, by the way, which we learned last week, right? Mm-hmm. Now we're going to plug that into here. So this is going to be the limit as h approaches 0. F of 3 plus h we said was 9 plus 6h plus h squared minus 9 over h. Now let's simplify. The limit as h approaches 0, the 9's will go away, and I can factor out an h from the top, so I get 6 plus h over h. What happens to the h's? Cancel out. They cancel out, so I have the limit as h approaches 0 of 6 plus h. Look at that. So what is the limit now? 6. So the slope of this curve at that point is 6. Okay, so m equals 6. Okay? We're going to do one more.
How did you measure this?
In this case, we're going to do the preliminary work before. All right? So our formula is the limit as h approaches 0, f of x plus h minus f of x over h. Right? So I know that I'm going to need f of x plus h. So f of x plus h, in this case, is f of, what is x? Negative 2. So it's negative 2 plus h. So let's see what negative 2 plus h is. If f of x is x squared plus 4, then f of negative 2 plus h is negative 2 plus h squared plus 4. That'll be 4 minus 4h plus h squared plus 4. Okay? So f of negative 2 plus h is h squared minus 4h plus 8. Now let's go back here. This is the limit as h approaches 0 of, I have f of x plus h, which I already found. That's h squared minus 4h plus 8 minus f of x, which is f of negative 2, which is 8. So remember, initially, this is my x and this is my f of x. Okay? Over h. So this is the limit as h approaches 0. These will go away and I can factor out an h. You're seeing a pattern now, I hope. H minus 4 over h. The h's cancel out and I can find the slope. By direct substitution, this is the limit as h approaches 0 of h minus 4, and if I directly substitute 0 in there, then the limit, then the slope is equal to negative 4. Okay?
Will it always do that?
Yes. In the next case, it says to find an equation for the slope at any point. So we don't have a specific point. We need to find an equation of the slope. So our answer is going to be in terms of x, right? It's going to be m equals 3x plus 7, let's say. Right? So we're not plugging in any specific values. Now, let's write down our equation. M is the limit as h approaches 0 of f of x plus h minus f of x over h. Now, I need to find what f of x plus h is. Okay, so let me do that first. What is f of x? F of x is my y. In this case, it's x squared minus 4x plus 2. Now I need f of x plus h.
So is it x squared minus 4x plus 2?
F of x plus h. Wherever you see an x, we're going to insert x plus h. So it's going to be x plus h squared minus 4 times x plus h plus 2. Now we need to distribute the square. So this is going to be x squared x squared plus 2xh plus h squared minus, we distribute the 4, x minus 4h plus 2. So finally, f of x plus h is equal to x squared. Well, there are no like terms here. So we can just insert that into our formula. So this is the limit as h approaches 0 of f of x plus h. We just found that. It's this long string right here. So I'm going to insert that in here. X squared plus 2xh plus h squared minus 4x minus 4h plus 2. Now minus f of x. And we know what f of x is. So minus in parentheses f of x, x squared minus 4x plus 2 over h. Right. So now we need to do some algebra here. M is equal to the limit as h approaches 0 of, let's see, this is going to be negative x squared plus 4x minus 2. So x squared minus x squared goes away. I have 2xh plus h squared minus 4x plus 4x goes away, minus 4h. Oh, that didn't go, but the 2's will go away. So that's what we have left. All right, so do you see how it gets cleaned up on its own? And all this is over h. Now, we can factor out an h from the top, it seems. Right? So this is the limit as h approaches 0 of h times 2x plus h minus 4 over h. The h's will cancel out. All this is just algebra. And now, what we're left with is the limit as h approaches 0 of 2x plus h minus 4. At this point, all I have to do is direct substitution. Plug in the 0 into h. And what do I have left? 2x minus 4. So that's my final answer. So finally, the slope is 2x minus 4. Okay? So lots of algebra, but in the end, the reward is so gratifying because you have a simple equation for the slope. And with this, we can find the slope at any time, at any point. Okay? So now if I say, all right, find the slope of this curve at the point 2, 1, you can just plug it in there. Okay? All right. The homework due next class, Thursday, will be up to number 17.